All right, guys. So now we'll move on to the next part of the lesson. So we are gonna now you know how to get the line of best fit, right? So in the previous section, we discussed how to find the line of best fit by calculating SXX, SXY, the A value, B value, and we know how to get the line of best fit. And we also now know how to do predictions by using the line of best fit. So now in this part, we are going to learn how coding is going to be applied to regression line. So you recall coding from chapter 2. Do you recall? So why do we use coding? I mean, when you are working with large data values, I mean, we use coding to make things simpler for us, right? Okay, so here they are going to go with some sort of a coding here. So they say sometimes the original data are coded to make it easier to manage. You can calculate the equation of the original regression line from the coded one by substituting the coding formula into the equation of the coded regression line. Okay, guys. So what they're saying here is now instead of giving you the original data, they might give you the coded data. And then you find the regression line for the coded data, and then that line you convert to the original equation. How do you convert to the original? So as an example, now look in exercise 5D. They say given that the coding P is equal to x plus 2. So this is the coding. Okay. So P variable is used for x plus 2 and Q is y minus 3. Has been used to get the regression equation P plus Q equal 5. Okay. Okay. So the regression equation. So what's the regression line? The regression line is P plus Q equals 5. So P, now guys, this is the regression line. So what do you have to do now? You have to replace the P value. So what is P? P is x plus 2. Now understand here. The regression line is given to you. Okay, so it's given as P plus Q equals 5 and this is the coded regression line. So they are asking you to go back to the equation of the regression line of y on x. So how do you get the regression line of y on x? P is x plus 2 plus Q is y minus 3. Are you with me? Equals to 5. Can you see what I just did here? I replace the P value with x plus 2 and I replace the Q value with y minus 3. Are you with me? And then you get the regression equation of y on x by making y the subject. So you make y the subject. What do you do here? Take all the other numbers to the other side. Let's first simplify x. 2 minus 3 is minus 1 plus y equals 5. Agreed, right? Y equals 5 plus 1, that's 6 minus x. So y is equal to 6 minus x. Can you see, guys? So this is the equation of the regression line. This is just a very simple question. So we'll go into more complex one where we actually have to do the coded calculations. Okay. Okay, guys. So in the same exercise 5D, let's go to question number 5. They say a regression line of C on D is worked out using the coding x equals C over D and y equal D over 10. Now be cautious here, guys. Okay, in this case, the regression line is of C on D. The original regression line is supposed to be C on D is worked out by using the coding x is C over 2, y is D over 10. So what you need to understand in this question is x and y are what we use for the coded data. The original data is C and D. Can you understand? In the previous question, it was the other way. In the previous question, x and y was the original data, P and Q were the coded data. So just read the question very carefully, okay? Understand English there. So here C and D, the regression line of C and D is the original and the coding is XY. So XY is the coded data. Given that SXY, SXX, X bar, Y bar is given, calculate the regression line of Y on X. Okay, so you know what you should do. So get the summary. So summaries are given to you. Get the statistics SXY, sigma, sorry, these are all given to you, right? So we don't need to calculate it. Okay, we can directly go for B. B is equal to SXY over SXX. So SXY is 120 over SXX is 240. So I think this is a half, right? It's half. And then guys, A value, A is y bar minus bx bar. So y bar is 6 minus b is half, 0.5 or 1 over 2 into x bar, that's a 5. So guys, what do we get for this one? 6 minus 5 over 2. So that's 12 minus, so that's 7 over 2, right guys? Yeah, so we get A is 7 over 2 and we can get the regression line quite easily. Y equal A plus bx is the line of best fit. So y equal A is 7 over 2, b is half or 0.5 x. Are you with me guys? So this is the equation of the regression line. In this case, you don't need to, I mean, everything comes in exact figures, right? 7 over 2 is 3.5 plus 0.5x. All right, guys. Okay, so that's done. Part B. Find the regression line of D on C. So the regression line of D on C, how does that work? Now you have the XY. This is the chorded line. Remember now in this case, XY is the chorded line. They are asking you to get the regression line of D on C. That's the original one. So how do you get the D on C equation? So Y is D over 10. X is C over 2. Okay, right guys, can you see? So you replace the Y value with T over 10 and you replace the X value with T over 2. Right? Are you with me? Okay, so now make D on C is make D the subject. Okay, so make D the subject. We'll multiply the entire equation by 10 because it's over 10 is, you can multiply the whole equation by 10. So we get D equal 3.5 into 10 is 35. 0.5 into 10, that's going to be 5 over 2. So that's 2.5, guys. D equals 35 plus 2.5C. It is okay? Okay, all right. All right, guys. So we'll move on to question number 6. Some data on the coverage area, A square meter, and cost in C dollars of 5 books of flooring were collected. Okay. So the coverage area and the cost. Okay. So the cost to floor. Okay. The results were coded such that x equals a minus 8 over 2 and y equals c over 5. So guys, again, here x and y are the coded data. So can you see the coded results are shown in the table. So this is the coded result. Calculate sxy, sxx and use them to find the equation of the regression line of y on x. So guys, this is not at all difficult, right? The only difference in this sum is they have actually given you the coded data, not the original data. The original data has been coded. The original data is in terms of A and C. Okay. So you are supposed to get the regression equation of y on x. That's the coded one. And then I think next one they ask you to get the original one. Okay. So the first thing you should do is you should get the summary statistics. So you can see the x and y values are given here. You guys know what you should do. Go to the calculator, go to stat mode and give the data set. So you're supposed to get what? Sigma x square, sigma x, sigma y and sigma xy. We need these 4 summary statistics. So I have shown you now in several questions how to get these summary statistics. Okay, go to the cal, go to the stat mode, and then in the calculator that I showed you, you go to a plus bx and then you give the data, right? So you give the data point and then go for the summary statistics. Okay, or else you can do it manually. Okay, so anyway, I have shown how to do this in several questions in the previous work. So y'all can get it now. All right, guys. So I have got the summary statistics here, so you can easily get them from the cal. So now let's get the SXY is sigma XY minus sigma X sigma Y over N. So sigma XY 956 minus sigma X 49, sigma Y 81 over N 1, 2, 3, 4, 5 points. So let's get this answer, guys. And then SXX is sigma X square minus sigma X holding square over n, sigma x square is 671 minus sigma x is 49 holding square over n means we have 5 data points. All right, guys. Okay, so let's get these two answers, 5, 6y and 6, 6. Okay, guys, so all the working is now done here. You guys can see we got the S6Y, S66, these were exact figures. So we use them for B, S6Y over S66. And we got the answer. So B answer written to 3SF here. This is the exact figure. Okay. And then when you are getting the A value, remember now you have to input the B value that you got from here, right? So when you're inputting that B value, don't use a 3SF figure here because then otherwise we need A also correct to 3SF. So use the B value to a higher significance. Either use it to around 5 or 6SF, or you can use the entire figure here. I've used the entire figure and then I've corrected my A value to 3SF. Okay, guys. So then let's write the equation of the regression line y equal A plus bx. So this is the line of best fit. A is 7.87, B is 0.850 times x. All right, guys. So this is the answer for the regression line of y on x. Okay. So part B, find the equation of the regression line of C on A. How do you get C on A, guys? So what do you do to get C on A? Guys, you need to, replace, x is A minus 8 over 2. Y is C over 5. So simply replace. So this is part B, right? So let's replace y is C over 5 into x is A minus 8 over 2. All right, guys, can you see? So you replace the y and x. Okay. Y is C over 5, x is A minus 8 over 2, and they found to find the equation of the regression line of C on A. Meaning they want to make C the subject. Are you with me? You should make C the subject here. So let me write this again. C over 5 equals 7.87 plus 0.850 times. You can separate this as A over 2 minus 8 over 2 is 4. Are you with me, guys? Okay. So the simplification is entirely, you can do it on your own. You can do it the way you wish. This is 0.850 into A over 2. This is minus 0.850 into 4. You have to expand the bracket with 0.850. Right, guys? Expand the bracket with 0.850. And then you multiply the entire equation to make C the subject. Multiply the entire equation with 5. Are you with me? C over 5 into 5 is C. This is 7.87 into 5. This is 0.850 into A over 2. You multiply by 5. This is minus 0.850 into 4. You multiply by 5. Can you see what I did over here? Every single term was multiplied by 5. Right? Because you expanded the entire thing. Now here C over 5, when you multiply by 5, it becomes C. But every other term multiplies by 5, guys. So, and then now you can go for your regression equation. So the regression equation, you can see this term has A, but these two terms, you can add them. 7.87 into 5 minus 0.850 into 4 into 5, that you can get as your the part for the intercept, and the other part gives you the gradient. Okay, so the gradient is 0.850 into half. Okay, A over 2 means it's half. 0.850 into half into 5. And that gives you the A coefficient. Okay, so let's get these values in the calc. Alright, guys, so I added these two blue color sections together. And now remember, don't go for fractions because you have already used figures that are corrected to 3SF. Okay, so you can give the answer directly here. 7.87 into 5 minus 0.850 into 4 into 5. These two give 22.35. That's 22.4 correct to 3SF. This guy 0.850 into half into 5 gives 2.13 corrected to 3SF. So this is the regression line corrected to 3SF. You can write it down here because you can mention that you have actually written this corrected to 3SF. V1 over here, this one is corrected to 3 significant figures. Okay. So you can write it down. So whenever you are doing the correction, actually mention that you have done the correction by writing down the bracket. Inside the bracket, you say whether you've done 3SF or 2SF. Normally, we do 3SF correction. Okay, guys. So that's the regression line of C on A. And then estimate the cost of a box of flooring which covers an area of 32 square meters. So basically, the area. Now you can see some data on the coverage area A square meter. Can you see? So this is the 32 is the A value, and they are asking you to estimate the cost. Means they are asking you to find C. Can you see? Find C when A is 32. Are you with me? So here A is our independent, okay, our explanatory variable. Do you remember? So we are supposed to find the prediction for the response, the dependent variable. All right, so let's do this one. The A value is 32, right? So we are in part C. Part C, they are not asking us anything about the reliability, so we'll just substitute and get the answer. So C equals, what do you get here? 22.4 plus 2.13 into A is 32. Right, guys? So the cost will come in, what's the unit they have used? So cost in dollars. Can you see in the question? The cost in C dollars. Okay, so make sure you look at the units and see now over here the area is input in square meters. So make sure that you whatever the input you give for A is also in square meters. So those things are important. So here we use A as 32 square meters. So the units are correct, and then your C will come in dollars. So what's the value of C? Okay, so this becomes 90.56, or you can correct it to maybe 3SF or 90.56 or $90.6. All right, guys. So actually, what you can do here is, okay, so we can maybe try to, a better way of getting this would be, guys, over here now to get the cost to a better answer. The thing is, I have the thing here, I feel that this decimal might be off. Okay, so one way of, correcting that would be, guys, over here, you saw that we use 3SF figures for part D, right? Can you see? We use 7.87 plus 0.850. So one way would be that you actually use, in order to calculate the regression line, you use a few extra decimals for A and B. Are you with me? So instead of working with 7.87, you can increase another 3 decimals here for A. Increase 3 decimals for A. Okay, and you can increase 3 decimals for B. Okay, so these are B values. Here 0.850, you can increase another 3 decimals. Okay, so increase the A and B decimals, and you can use those increased decimals instead of working with 3SF. And then, guys, you can get here a line that's kind of like having around 6 significant figures. And then you can, of course, when you select the 3SF, you will definitely get this. This won't change. Okay, because the more decimals you use will not change the 3SF answer. Okay, so if you use a decimal with around 6SF here for these two, you will get these values with a longer decimal. Okay, and then what you can do is when you input the value A as 32 to that longer equation, the one with more decimals, your answer to 3SF will definitely be correct. All right, guys, are you with me now? Over here, there are so much approximations are happening. Okay, so anyway, I will go with this answer. So when we are doing past papers, I'll show you guys. Okay, so over here, actually, it's going to, since they have not mentioned anything very clearly, I'm going to go with this. But in the past papers, when we are discussing past papers, I will show you guys how we carry on the significance. Okay, but in the question, they have not mentioned anything very strictly. So we'll go on with this. Okay, guys.